Good morning, everybody. Hope everybody had a good weekend. Today, I want to wrap up the last of the topics heading into the exam here for chapters 13 and 14. And quick recap of everything that we have been doing. If we walk through, I covered a lot of different things in this chapter. All right, so we started with just saying this chapter was all about mixtures. And we said that was one of our classes of matter: elements, compounds, mixtures. We talked about what made those things up. And we said we're focusing on this last category: an element with an element with a compound, or two compounds together. But the important thing is they keep their individual properties. And then we got into our types of mixtures. We had homogeneous mixtures, we had heterogeneous, and we said we have solution, suspensions, and colloids. And then we went through the characteristics of each of those. And we talked about how if we were looking at a sample, we would be able to tell what was going on with those. And we had sort of a checklist, right? For looking at it, we decided if we can filter it. If it's a yes, it's a suspension. If not, it's a solution or colloid. And then how do we know the difference? We use the Tyndall effect. How does it scatter light? And we did the whole clear or cloudy thing. And then we went through all these different substances and talked about how those are. And there's videos on all of these, right? So if any of this seems really foreign to you, just go back through and you can find the video where we taught that on an individual day. Then we dove into, okay, well, how do we create these mixtures? And a really common theme is that we have to dissolve solids to make these mixtures. So then we talked about the dissolving process and some characteristics of the solutions after the fact. Can they conduct electricity? All right. What are some things that will affect how fast they dissolve? What are some things that will affect should they dissolve at all? And the whole like dissolves like. And we got into all of those ideas. And then we talked about the bends and how you've got gases acting different, right? And then we talked about some crazier molecules like detergent and how it seems to do both, and got into some Henry's law, and finally focused in on the temperature. And then we were talking about heat, and a really big idea that seemed to emerge when we started talking about the temperature is how heat can be tied into the intermolecular forces, which is an idea that is going to still show itself as we talk about colligative properties today. So we said we've got these heats of solutions. Sometimes when things mix, it's endo. Sometimes when they mix, it's exo. We talked about how do we figure that out, and we said it's the strength of the IFs that tell you what that process is going to be. And in any dissolving process, you have two things getting broken apart, which is endo, and one thing that's coming together, which is exo. And we said, depending on how strong those forces of separation or those forces of attraction become, what happens is we have an overall process that needs heat or gives off heat. And we called those heats of solution. And we said there are these things called solubility curves that will give us an idea about those. And that was the last thing we had talked about last week, where we looked at our solubility curves and the things that were important about those. And then to wrap up that idea, we started talking about measuring the power of solutions with some of our math problems, with molarity, with molality, and lastly with percent by mass. All right, so what I'm going to talk about today, though, is a bit of both. We're going to get into the last bit of not math, which are called colligative properties. And then I am going to attach to you a math practice PowerPoint, right, to see if you are doing okay with the math. And what we'll do is tomorrow during our regular class time at 1 o'clock, I'll jump on to the Google Meet, and If you're not getting the math answers, I will answer any and all questions related to the math problems. And then after class tomorrow, I will give you guys your test on this and what we want that to look like. And then the rest of the 5 or 6 days we have left, we're going to dive into acids and bases and finish those things up. And believe it or not, we're at the end of the year. All right. So like I said, today I wanted to talk about what they call colligative properties. And colligative properties are ones that don't care about who is dissolved in this beaker. They simply care about how much, all right, which we call concentration. All right, the properties that are dependent upon the concentration of just the solute, but not who they are. So whenever we start to dissolve solid into the liquid, they keep their properties individually. Water is still water. The salt is still salt. The sugar is still sugar. But what happens is you start to affect the liquid a little bit. And there's some things that happen to the solvent because the solute is in there. One of which is it elevates its boiling point. It makes it more difficult to boil a liquid when you start dissolving solid inside of it. And the reason has to do with what has to be done for something to boil. And we talked about that before. For substances to boil, we need these particles in the liquid to both overcome the intermolecular forces that hold them together and fight through the atmospheric pressure holding them down. Right, so if I add a solid into the container, it doesn't change the atmospheric pressure, right? But if I add a solid into the container, what it can do is create new connections with these solvent molecules. So when we put a solute in a solvent, additional IMFs, intermolecular forces, are created between these pinkish purple molecules and the blue ones that were there. And because there's new and more intermolecular forces, it takes a greater amount of heat to separate them, and the temperature at which it will boil elevates. It rises because of that. All right, so we can elevate something's boiling point, all right, by putting solid into the liquid. New IFs get formed, and the temperature rises. Right? Another thing that happens has to do with its vapor pressure. Right? We lower the vapor pressure. All right, so ties into boiling as well. All right, so if we raise the boiling point, it becomes harder to boil. So what happens is the particles that used to be able to escape and collide up here can't escape as easily now. So if I put equal temperature to both of these, say 100 degrees, the pure solvent has less IFs, so more blue guys get to boil and escape into the gas phase. But if I put the same 100 degrees to this beaker that has blue particles with the red particles in there, the red particles form additional IFs and less gas is able to be created. And as you can see here, the additional IFs make it so that less liquids are able to escape to the gaseous phase. And because of that, less gas particles above the liquid means less collisions, less things bouncing around, which is our definition of pressure. So the same reason we would have to heat it more to get it to boil means that at equal temperature, less particles get to be a gas, so the vapor pressure lowers because the liquid temperature rises. The last one's probably the trickiest of them. Right? It gets harder to boil and the vapor pressure lowers, but the last thing that happens is the freezing point depresses. It becomes harder to freeze a substance, so we have to lower its temperature more. And this is one we use all the time in PA. We want to melt the snow and ice off of our roads. So what do? We go out and we salt them. Right? And some people think that the salt laying on the snow and the ice is somehow giving it heat and melting it. And that's not really the case. What's really happening when we put salt on the roads is the salt gets dissolved in the little bit of water that's in the ice on the surface. And once that water dissolves the salt, it starts to lower the freezing point of the ice. So because the ice's freezing point gets lowered, the air temperature around it is now enough to overcome the forces that we're trying to form in the solid. All right, so this is backwards of the other two. So right here, this beaker here on the left that has only green particles, if I want a solid to freeze or melt, these guys have to come in and form IFs to connect together. So whenever it's just water all by itself, that happens relatively easily. The waters get near each other, hydrogen bonds form, all right, and we get normal freezing points. So the particles in the first beaker can easily shift into the solid phase from the liquid phase when we take enough heat away. We slow these guys down and intermolecular forces take over. But if I start putting salt into that, all of a sudden, the green particles have a more difficult time finding each other to form their IFs because there's stuff in the way. There are blockers stopping one green particle from forming a force with another. So what happens is we have to slow them down even more than usual. All right, so the particles in the second beaker are blocked by the red guys, so they can't form intermolecular forces as easily. So we have to cool it down more than usual. And we're using the reverse of that logic when we melt the snow. We lower its freezing point, all right? And what happens is these red particles, right, start to form IFs that aren't the right IFs, and it pulls the green particles apart and the ice melts. All right, so those are your three things that happen whenever you dissolve a solute in a solvent to create a solution. You elevate the boiling point because new IFs are formed and it's harder to overcome them. You lower the vapor pressure because new IFs are formed and not as many liquid particles escape to become a gas. And you lower the freezing point because those solute particles act as blockers in between your solvent particles. Right, so nothing too crazy. That was the last of the topics. Like I said, I'm going to attach the newest version of the PowerPoint, and I'm going to attach the practice math problems, right, that we will break down tomorrow if you are struggling, into the Parent Square post that is going to come out momentarily. Shoot me a message if you have any questions on either of those things. No formal 1 o'clock meeting today, but we will have our formal 1 o'clock meeting tomorrow for any math questions related to the PowerPoint or just topics in general. Hope everybody is doing well, and I look forward to seeing you guys again soon.